everyone, this is Grayson Nicholson, the host of the Austin Peay Experience podcast. Welcome to the Austin Peay Extras, the podcast series where we share the fascinating talks and lectures hosted by the university each semester. We're back with the most recent Science on Tap, featuring Jody Alberd, Assistant Professor of Engineering Technology, presenting his talk, The Robot Revolution, Navigating AI, Automation, and the Workforce of Tomorrow. Enjoy!
All right, welcome everybody to Science on Tap, our October 3rd edition. Thank you so much for coming tonight. My name is Karen Meisch. I'm the Dean of the College of Science, Technology, Engineering, and Mathematics, College of STEM. And of course, our purpose tonight, as with every Science on Tap, is to try and help the community understand a little bit about certain topics in STEM. And so tonight's topic is going to be very interesting and wonderful, given by Professor Jody Alberd from Engineering Technology. I'm going to let him introduce it, and then, as always, you'll find that there are comment cards on each of your tables, and so please make sure you fill those out. Not only is that a great way for us to generate more ideas about the topics we can cover on Science on Tap, but it's also how we can actually draw our prize for the end of the Science on Tap talk. At the end of the talk today, we'll also be having a really fun reveal of the name of our robot dog that you might have seen walking around earlier tonight. And so we'll do that at the end of the talk. And of course, I was trying to give a plug for next month's talk. So November 7th is next month's talk, which is Election Day. And so, how democratic is our democracy? The math behind politics. So, given that it's election day, we thought it might be a good time to delve into some of the math behind politics for next month. All right, and without any further ado, I'm going to go ahead and turn it over to Professor Alberd.
Hey. All right, thanks everybody for coming out. My name is Jody Alberd. I'm a faculty member at Austin Peay State University in the Department of Engineering Technology as part of the College of STEM. I am originally a manufacturing engineer by trade. I've worked in a lot of the regional industries from Electrolux to Trane, commercial insulating glass out in Cumberland City and MSSC in Hopkinsville. So I have a deep interest in technology, specifically in manufacturing. Oh, I gotta hold it really close. Okay. I'll try to be a loud talker, and I'll try to remember to keep this up. If I tend to drop my hands as I do in class, just give me a quick reminder. So without further ado, in 1976, I was 6 years old. And I was standing in line at the Capri Twin Theater here in Clarksville. And I was waiting for a movie to come out that I had never heard of called Star Wars. And by the end of this movie, I was fascinated. And I was enchanted by the star of the movie, the protagonist, the hero, R2-D2. Now, you couldn't convince me that R2-D2 was not the hero of this story. Everything happened because of R2-D2. Luke Skywalker would still be a moisture farmer hanging out at Tashi Station with his friends. But I was enchanted with technology at that point. Sci-fi began to hold an interest, and as I grew through my life, sci-fi continued to hold my interest with television shows such as Star Trek: The Next Generation, and other movies that came along during that time. And I began to develop a deep love for technology because in every utopian vision of the future, we accomplish great things alongside technology. And as I grew into adulthood, I began to see some of these things that I saw in technology actually coming into fruition. All of a sudden, we had computers that we could interact with by talking to. We were able to communicate with each other over vast distances. We had computing technology in the palm of our hands that had access to limitless information. And I was excited about the future and what all this technology was going to hold for us. And I was looking forward to such great things that technology promised. But as I continued to see these things become more common in our everyday lives, I began to notice that there was a reluctance, a hesitancy, and sometimes even a fear of what this technology meant for the future. And as I saw this happening, I began to ask myself, what happened? When did we all of a sudden start dreading a future alongside technology? When did we stop embracing the excitement and the promise that it held? Now, it's a very complex topic, and it has a lot of aspects, but I want to focus on one tonight, and that's how is this going to affect us in the workplace? How is this going to affect our future and our jobs further down the line? So tonight's talk is the robotic revolution, navigating AI, automation, and the workforce of tomorrow. Now, it would be appropriate to start this off with just addressing the elephant in the room. What are our concerns? What are our doubts that we have about technology? And when we label concerns and doubts, they take two very different characteristics. Under our concerns, we may ask questions such as, will a robot take my job? How is this going to affect the economy? What about my data and my privacy? What about my ability to make decisions for myself in the future? And most importantly, is it going to be safe? Now, on the other spectrum, we have doubts. And these doubts are a little less tangible and a little more subjective. We ask questions like, and make statements such as, I don't understand how it works. Maybe we are concerned with whether it's going to last. Is it going to be something that we need to even be concerned with? Is it going to be around tomorrow? Google Glasses. Maybe we don't think that it's actually useful to us, and we don't see the purpose of it, or we don't think it's reliable. And again, we just have a hesitancy because of concerns about safety. Things that we can't necessarily quantify, but we can articulate. The truth is that none of these fears or concerns are unfounded, but neither are they new. These concerns have gone back over 200 years. If we go back to the first industrial revolution, which was occurring in the late 1700s and the early 1800s, we saw the mechanization of the textile industry in Great Britain. That's when they began taking jobs that had traditionally been done for generations by manual labor and converting them into machine processes. And that's when we saw the rise of a group called the Luddites. The Luddites were a 19th century movement of English workers, and they were opposed to the mechanization in the textile industry. And they took their name after a figure of folklore called Ned Ludd. And much like Paul Bunyan or Johnny Appleseed, Ned Ludd was believed to be based on a real person. He was actually someone who had sabotaged industrial equipment, and they saw him as a symbol of their movement. So they began to engage in industrial sabotage. They began breaking the machines that were taking their jobs or that they saw as a threat to their future employment. And this led to legislation, and more importantly in 1918 or 1812, the Frame Breaking Act. And this made that the destruction of industrial equipment a capital offense. Luddites who were punished under this act were actually subject to penal deportation and even the death penalty. Approximately 60 to 70 Luddites were hanged over a 2-year period for destroying and sabotaging industrial equipment. This was a significant impact on the gross national product of Great Britain at the time. And today we use this to describe someone who is opposed or resistant to new technology. Now, over that 2-year period, the Luddite movement began to fall out of favor and it began to fade out. But the concerns and the fears and the doubts continued and persisted even into the modern age. We now have what we refer to as Neo-Luddism. Neo-Luddism is a leaderless movement opposing many forms of modern technology, and they do so for a variety of reasons, whether it's for environmental reasons or concerns, or for labor concerns, or even ethical concerns. And this brings us to the Luddite fallacy. The Luddite fallacy is the mistaken belief that there is a finite amount of work available. And if we have machines do all this work, there won't be left for any of us to do. And we call this a fallacy because historically this just hasn't proven to be the case. Now, there are many prominent Neo-Luddites. One of the most prominent was a math prodigy known as Dr. Theodore Kaczynski. Theodore Kaczynski, better known as Ted Kaczynski or the Unabomber, in 1969 left his teaching position at UC Berkeley and adopted a lifestyle of avoiding and eschewing technology. He moved out into the woods into a cabin where he had no running water, no electricity, and he began to send a series of explosive devices for over 20 years, devices that killed and maimed several people. So the tactics of Neo-Luddism have taken anywhere from just a peaceful protest to a more radical, aggressive stance of it. So are they right? Are the tendencies of Neo-Luddism incorrect? Well, yes and no. While it is true that machines can do work that was traditionally done by human labor, the truth is that they typically do the easy work. We have them do the things that are simple. They require less skill, less talent, less knowledge, and that typically tends to be where machines come into play first. The difficulty of that statement, though, comes into the fact that what we define as easy begins to get higher and higher as technology advances. See, there's a small window that goes above what machines can do that human workers have to do. But then we reach a peak of what we can accomplish. There's only so much computing that we can do. There's only so much information we can process at a given time. The work that lies beyond what we can do as human beings requires us to turn back to technology. Now, as technology advances, that window does tend to get smaller and smaller. What we looked at as easy work that we could easily automate starts taking up a greater amount of space. Another Neo-Luddite, self-described, was Stephen Hawking. And Stephen Hawking said that the means of production will be controlled by the machine owner class, and technology will create more economic equality. So, is he correct? Again, we look back at history. When we look at those who controlled oil production and those who controlled steel production, yes, there was a class that played into that technology that were able to control that technology. So Neo-Luddism does have a very real statement to make in that context. But we need to look at it with a more open mind. So we get to the question at hand. Will a robot take my job? Probably yes. It's not a popular statement to make, but probably. But the real statement is it going to be a job that you don't want a robot to take? In 2013, Oxford University completed a study that suggested that 47% of jobs were at risk of being automated over the next 20 years. So between 2013 and 2033, 47% at risk of being automated. And that's an alarming figure. But it's really kind of a figure without context. When we say that jobs are at high risk, what kind of jobs are we talking about? What kind of tasks? More recent studies have indicated that automation doesn't replace jobs. Automation replaces tasks, and it's very important to understand that distinction. We perform tasks in the performance of our job. And while we may automate certain tasks within that job, the idea that our job will be eliminated completely is part of that Luddite fallacy. In truth, automation, again, doesn't replace jobs, it replaces tasks, and this frees workers up to perform other tasks, other things that we can do, things that would be more productive, more value added. And we know this is true because we can simply look at something like the agriculture industry. In the early 1900s, the agriculture industry employed 41% of the nation's workforce. 41% of our nation's workforce were engaged in the agriculture industry. A century later, only 1.9%. From 41% to 1.9%. And this number continues to drop as we continue to see advances in the agriculture industry. This was brought about largely due to mechanization in the form of tractors and combines and machines that are able to do the work much faster and more efficiently than we could expect human workers to do that work. And this has been driven also by our increase in demand. As our population has grown, we have an increased demand for agriculture. It's predicted that robots will continue to assume tasks such as planting, weeding, and sorting out units using AI-enabled cameras, and that 1.9% is going to continue to drop. So if we went in a century from 41% to 1.9%, what happened to the unemployment? Why have we not had 39% unemployment over the past century because of automation in agriculture? Because automation replaces tasks. It doesn't replace jobs. Those workers have found other opportunities and other avenues, and we'll talk about some of those in just a few minutes. Now, I said at the beginning that I'm a manufacturing engineer by trade, so my area of interest typically lies in the area specific to manufacturing. So what about the role of robotics in manufacturing? Robots in manufacturing really hit a surge in the 1970s. Even as a child growing up, I was aware of the impact that robotics was taking in the automotive industry, as well as the concerns that it began to present. In 1969, the Stanford arm was developed with 6 degrees of freedom, and that's typical to what we see in industrial robotics today. This boom continued into the 1970s, and today, robots are essential in keeping automotive plants competitive, with over half of the industrial robot purchases in North America being made by automakers. That automation has not necessarily driven large-scale unemployment. What it's done is kept the automotive industry competitive, has kept them functioning, and able to meet the demands of an increasingly mobile society. But what about within our industrial environments and our facilities today? Forklift accidents. There's not an industrial facility in the country that doesn't have forklifts. We use them for material handling, we use them for material positioning, and there are millions of forklifts across America in industrial environments. But they result in 34,900 injuries and almost 62,000 non-serious injuries every year. When you look at environmental safety and health department of most manufacturing facilities, one of the areas of concern is forklift operations. because they're entirely based on human interaction. We have human forklift drivers, we have human people walking around a facility, and these accidents are driven by any number of factors, whether it's driver fatigue, worker complacency, not looking when they step out into a traffic path. So these safety concerns are definitely something to be worried about. But OSHA estimates that 70% were preventable and that they were based on human error. Now, a lot of facilities have begun turning to automated guided vehicles for material handling. These automated guided vehicles, or AGVs, are a $1.31 billion market, and it's expected to double in the next 5 years. Right now, facilities such as Amazon is one of the largest users of AGVs, so much so that the company they were buying all of their robots from, they just bought the company. And now it's Amazon Robotics. It made sense. 520,000 automated guided vehicles in Amazon plants across the country. That's more than all other industries combined. But more facilities are seeing the value of replacing their forklift fleets with automated guided vehicles, in terms of safety to workers, in terms of safety to material, and safety to the facilities. So there are trade-offs. They're slower, about 50%, but they've proven to be safer and more consistent. They're not as versatile, so do I expect that forklift drivers are going to become obsolete over the next 5 years as we double that industry? No, probably not. Forklift drivers still have a role to play in our manufacturing facilities. Forklifts are a lot more versatile. They're able to perform and accomplish things that automated guided vehicles just can't do. They don't have the agility. They don't have the ability to be versatile in that environment. So I do think that we're going to continue to see forklifts, but the average life of a forklift is about 20 years, depending on the model and the maker. So 20 years for a forklift. And I think as we begin to see these forklift fleets start to age out, rather than replace those forklifts, I think what we're going to see is companies begin to turn more and more to automated guided vehicles to solve their material handling solutions. So what we're seeing in industry is that the role of robots is evolving. We're going from a high volume automotive only technology to something where now we're asking, where can we put a robot? Where can a robot fill a need? Where does it add value to our enterprise? Now, currently the manufacturing industry employs about 11% of the US workforce. 11%, 1 in every 10 workers is employed in a manufacturing facility somewhere in the US. This is an actual decline over the last 5 years of about 1.4%. As more jobs become automated, we're noting a decline. But the question that we really need to ask is, has this increased automation driven the decline in labor? Or has the decline in labor driven the increase in automation? It could be 50-50. My experience is that we're facing a labor shortage. Most manufacturing facilities are competing for labor in their facilities and are competing with other facilities in their region. Does anybody know what the starting pay at a manufacturing facility for someone coming off the street with no skills or qualifications whatsoever prior to or prior experience is going at right now? 20 to 21 an hour. When I left Electrolux 3 years ago, it was between $20 and $21 an hour. And that was because all of the other facilities in that area had started hiring at 19 and 20. And it's not because they can't find people who are willing to work. There are a ton of people willing to work. But for whatever reason or choices, we have a shortage in our labor pool. If we need 100 people in a facility and we can only hire 80 people, what do we do about the other 20 jobs? I can only get 80. I've offered as much money as I could possibly offer, and I still can't get the workers in the door. Well, the answer is we have to automate those 20 jobs that we can't fill. So is the decline in labor driving the increase of automation? I would say yes. As our demands increase, as we begin consuming more, it's going to continue to drive increases in the necessity for automation. Despite economic factors, we consume now more, and we have a greater demand for manufacturing than we have ever had at any point in our history. So manufacturing increases, the demand increases, our need for tasks to be performed increases, but our labor rates are kind of remaining the same. So automation helps us fill those gaps. But what do we automate? What jobs should we automate first? What are the jobs nobody wants to do? In robotics, we call it the 4 Ds, the dirty, dull, difficult, and dangerous. These are the jobs nobody wants to do in the first place. You can't pay me enough to do a dirty job. Okay, maybe you could pay me enough, but not enough that makes it economically feasible. Dirty jobs, painting. Painting is a dirty job. Dull jobs, monotonous, repetitive jobs. At LG, there's somebody getting paid $20 an hour to shoot screws in a dishwasher over and over and over again. And it's a boring, monotonous job, and it has its own ergonomic challenges as well. Difficult jobs, jobs that are just too hard for us to do or too complex. Perhaps we just can't keep up with the pace needed to meet the demand. We can't just tell workers work faster. That's really not an answer. So we automate. And jobs that are dangerous, jobs working in dangerous environments that are hazardous to our workers. Why put people at risk when I can just automate that job and make it safer for everyone? Now, we speak of these in terms of robotics, but this applies to any implementation of automation. If we're going to automate, this is the first area we look for. What are the 20 jobs out of 100 I cannot find anybody to fill because it's a dirty, dull, difficult, or dangerous job? So what are the results of this? Increased automation. Well, first is job displacement. In some sectors, you're just going to see robots and automation replace these tasks that are dull, dirty, difficult, and dangerous. But you're also going to see job creation. The deployment of automation historically has resulted in a net job increase. That's right, automation is a net job creator. These jobs typically revolve around other associated functions necessary to support automation, maintenance and operations, the development, innovation, and the implementation and integration of automation systems. And sometimes it's entirely new industries that are created. I had a conversation with a gentleman before we started tonight, and we discussed about 100 years ago, my grandparents could not fathom or conceive of the jobs that would be available to us today. And I can only imagine what type of jobs and new industries are going to be created 100 years from now. Job transformation. In many cases, automation just transforms a job rather than eliminating them. One of the examples I like to give is I was automating a process when I worked at a manufacturing facility, and I had an operator who had worked on that process for 10 years. They were super proficient at this job. They were very good at it, but it was a very labor-intensive job. So when we automated that, I needed an operator who could watch and observe and monitor that automation. Who better than the person who had been doing it for so long, who could note any variations in the process, any errors or mistakes in the automation equipment? Who better than the operator that had been doing it by hand to now monitor the automation doing the job? And that's what we did. We began transforming that job from one of manually performing a task to monitoring the automation that was performing that same task. And as a result, we ended up with an operator who was able to give better feedback, was able to notice much earlier in the process when the system was failing, and we had a stronger process in the end. A lot of times these tasks require more problem solving, creativity, and human judgment, and that's where our operators really excel. Doing the dull, dirty, difficult, and dangerous jobs are not where our operators excel. They excel in being able to use their own creativity and problem solving. Sometimes there's industry-specific impact. Has anybody been to the noodle place? They got the robot that comes around and serves your food to you. What's the name of that? I'm not going to say because I don't want to compete with Strawberry Alley. I do love their food here. But I have not been. I had a student who was bringing that up to me, that there's a noodle place that has a robot server come around to your table. Certain industries are already shifting into automation. They're finding these jobs that in the food service industry, for example, now there's these self-serve kiosks where you can just order your own food. The food service industry has a huge labor shortage. So they're automating the jobs. And why are they automating them? Well, they can't find people to do the jobs, but we still want our burgers and fries. We still want to go through the drive-thru and have our order taken. We still expect that service. So certain industries are seeing this impact sooner than others. Whereas some industries that require that creativity, that emotional intelligence, and the decision-making are less likely to be automated soon. But eventually, we're getting there. Sometimes they're complementary roles. Automation technologies are designed to complement human workers. We have what's called cobots, or collaborative robots. And these are robots that are designed to work with a worker. The robot will pick up the materials that may be too heavy for the worker to manipulate, or ergonomically unsafe for them to manipulate. And it'll present the work to the worker, who can then perform a complex task on that work. And we're seeing that more and more in industry. Collaborative robots are safer, they're more able to be integrated, and they work better with complex tasks that still require human intervention, but would benefit from automation. Economic and social factors. The broader economic and social context also plays a role. The government will continue to make policies. Labor unions will still have a voice. And the labor market and society impacts are still going to have to be a factor that we consider, and how it's going to affect our employment in the future. To mitigate this, though, we turn towards reskilling and education. Upskilling workers to prepare them for new roles that align with the changing job landscape. As I said at the beginning, I teach engineering technology, along with my friends Matt and Mahesh. We see a large number of students coming through who currently work in an industrial environment but want to upskill. They see the value that automation is bringing. They see the impending increase in automation, and they want to get ahead of that curve, so they begin upskilling and training and education. And sometimes employers do that themselves as well and support that. What about that question, is it safe? Self-driving vehicles have become a hot topic lately. We see it on the news quite frequently. This is the Waymo. According to Allstate, a typical driver goes 165,000 miles before an accident. On average, the amount of driving we do in the US, 165,000 miles. Waymo, which if you've never heard of Waymo, you might recognize it as the Google self-driving car. They actually branched off into their own subsidiary, and they're running what is a self-driving Uber service. They're being marketed or tested in Arizona and San Francisco. And for many years, they drove with a safety driver behind the wheel, but now they're completely autonomous. Teslas are not self-driving. Teslas have an autopilot feature that is not a self-driving feature. Tesla is a Class 2, and Waymo is a Class 4 in terms of automation. In 1 million rider-only miles, with no driver or human interaction whatsoever, they've only logged two collisions that required reporting to the National Highway Traffic Safety Advisor. 55% of the non-reportable accidents involved human drivers hitting a stationary vehicle. And in almost every case, human drivers violated road rules or behaved dangerously in every vehicle-to-vehicle event. Their safety record is amazing. So we have concerns about the safety, but the data and the statistics show us that they have a very good safety record, and they've had no reported injuries in 1 million rider-only miles. Uh-oh, I lost 2 TVs. There we go. What about tractor trailers? My father was a tractor trailer driver for 10 years. Trucks account for 4% of the vehicles on the road, but they're involved in 9% of the fatal crashes. Huh?
He's on the wrong side of the road.
He is on the wrong side of the road. I didn't notice that. Now this is actually a driverless vehicle that's being tested. So it is on a test track, or I flipped the image, one of the two. So would self-driving in vehicles improve that safety record? If we began looking towards the mechanization or the automation of our truck driving industry, which we rely on heavily, would that improve that safety record? The data and the statistics point to yes. Is that a likelihood? Probably not right away. The implementation and the integration of the technology is significant. The cost would be very significant, but truck drivers are already taking note of it and beginning to look at ways they can upskill as well. And again, truck driving also is being affected by that labor demand. They're also being affected by that struggle to find people that are willing to drive. So is automation in the trucking industry inevitable? At some point I would say yes. Yes, it is inevitable. Will it happen tomorrow or in the next 5, 10 years? Probably not. But it is inevitable, and our workforce has got to start looking and preparing for it. What about ChatGPT and artificial intelligence? That's really hit the news lately. I like this photograph because I'm a big admirer of His Holiness Pope Francis, and I know in my heart of hearts that he would never wear an outfit like this, but the photograph is so good that I had to double check. It just looks so real. And it's actually an AI-generated image that went viral a while back. And ChatGPT is a language learning model, and you can read, I actually generated this slide from ChatGPT, which I thought was pretty awesome, because they did a great job of describing it. I don't know that I could have described it as well. It takes a large data set of text, and it's able to take an input and provide an output that at this point is almost indistinguishable from human interaction. And that's generated concerns. I just heard, it's scary. It's a concern because how do you know if you're actually communicating with a human or automation? Now, ChatGPT is just one model. There are actually, I checked, I saw at least 36 language learning models that are currently available, and more are being developed incrementally. The WGA, the Writers Guild of America, and the Screen Actors Guild are currently on strike because they're protesting the use of AI on the basis that it supplants creative artists and writers. The intro credits to Marvel's Secret Invasion were AI generated by Method Studios. Now, their concept artists for Marvel Studios commented on this. Secret Invasion is AI generated. I'm devastated. I believe AI to be unethical, dangerous, and designed solely to eliminate career artists. And that concerns me because of two words, I believe. No quantifiable evidence, but just I believe. I think Mr. Simpson is just looking at it from the wrong angle. So is it unethical, dangerous, and is it designed to eliminate artists' careers? Nothing could be further from the truth. It's simply technology. Technology is developed with the intent of helping people. Are they unethical by using source material without attribution? Well, that comes back to the user. How is the user using that technology? And does it replace creativity, or can it support more complex creativity? Well, the answer to that is in the strike itself. The WGA and SAG strikes have set the movie and television industry back significantly, and they've estimated that it's going to take a significant amount of effort to get their productions back on track. Oddly enough, the same thing that was a concern might actually be the solution. The solution being suggested is using these AI generative tools as a supplement to the current creative endeavors being put forth to help get it back on track. That it can assist writers and it can assist artists. None of these things, even the Secret Invasion intro, are completely done in a vacuum. They do require artist interaction, and Method Studios has stated that they've actually seen an increase in their workforce because they needed more people in order to generate that introduction. So again, it's created jobs rather than replaced jobs. Ultimately, AI integration, much like CGI, has a greater value as a tool to augment the current workers than to supplant them. It has the ability to create opportunities for increased productivity without putting excess pressure on workers. Simply telling them to work harder and faster is not going to be the good answer. We can use it to streamline data processing and customer service. Everybody's gotten those phone calls about your car's extended warranty. Go ahead and update that before you break down. But we get the calls. We don't like the robocalls. We've called for customer service, and we've got the AI-generated customer service. Please state the nature of your problem. But ultimately, it helps us streamline those services. It helps with software coding, because while it can generate certain lines of code, it is not perfect by any means, and it still requires human interaction to touch it up. It can help with marketing design and so many other areas. One of the areas I ask is in education, how can I encourage AI integration while maintaining creativity? And computer science actually had the answer to that. So during the most recent innovation experience that we do in the College of STEM every April, one of the student projects in the computer science department was developing a card game application that I was very impressed with. And they stated to me that one of their biggest challenges was they're not artists. They don't create artwork. They're programmers. And they had created this game, but they needed a lot of artwork. So they used an AI generative program to create the artwork for their game. because ultimately it was a programming project. And as a result, they were able to complete their project in time. So in my opinion, we began, instead of worrying about ChatGPT taking away student creativity, we look at opportunities to increase student creativity. We look at ways in which we can encourage them to use AI generative programs to help increase the quality of their end product. In engineering technology, we're not writers, we're not creative, we work with technology. So when my students have to communicate, not so creative. They communicate well in technical terms, but maybe I need them to communicate in layman's terms. This is where generative AI can help out. So what do I do if a robot takes my job? Well, in the US, we've begun embracing a technology or a concept known as Kaizen, or change for the good. This overall philosophy embraces reduction in waste, and workers aren't seen as a waste, but they're seen as a resource. And that by investing in that resource and that concept of value added, we get a better trained workforce that is more reliable, more productive, and overall a general happier workplace. Relying on new employees to come in with the required training that we need for this increased automation is not going to be sustainable, not in the competitive labor market that we have. Historically, I've said that technology has resulted in being a net job creator. In many industries, there's a likelihood of a lateral conversion to a new and better job, and implementation of new technology takes time. It requires us to allow workers to acclimate and prepare for new roles. We're already being acclimated to technology. If you've checked out of a grocery store or a department store recently, you've gone through a self-checkout or seen the self-checkouts available. That's acclimating us to a time when we don't even have to check out. We just have RFIDs on our products. We select them from the shelves and we walk out. We're beginning to acclimate to new technology, and the resistance to that change is certainly a concern. Many times jobs require retraining, and in Tennessee we have a lot of programs designed to help support that. We have Tennessee Promise and Tennessee Assure, or Tennessee Reconnect, which helps students out of high school as well as adult learners get some of that retraining that I talked about. A lot of employers provide tuition assistance for their employees to be able to go, or tuition reimbursement programs for them to be able to go and get those upskills that they need in order to be competitive in a labor workforce. Many offer in-house training, and Tennessee even has worker training grants that are provided to employers to incentivize them hiring lower skilled workers and training them up. Overall, the net impact of automation in the workplace is going to depend on how the businesses, government, and society embrace it. How do we adapt to these changes? How do we invest in education and workforce development to help us upskill and prepare our workers for the increased automation in the workplace, and beginning to foster innovation in emerging industries? The future will involve continued advances in technology. History has shown that you can't uncork that bottle. Technology is going to continue to advance, but it's our human capacity to utilize these advances to our greatest potential that will dictate what the future looks like. So overall, I like technology. I think it's positive, and I think we have reluctance and concerns, and we address those. But we can't ignore it, because it's still going to happen. But if we ignore it, we're not going to be prepared. So that's my talk for today. I appreciate you coming to hear it. Don't forget, we do have a partial solar eclipse coming up on October 14th. That's going to be happening, I think, around noon. I think noon is the best time to see that. Are there any questions?
So computers have been around for like 70 years.
Mm-hmm.
And at some point, this computer that's adjacent and a computer that's AI, you cross some sort of boundary. Is that definition accepted and understood as Windows just a computer computing become a computer that's doing AI?
So when does a computer that is computing become a computer that is doing AI? And I think, not being a computer expert, because I'm engineering tech, but I think that computers, when we define it as artificial intelligence, is when it is able to exhibit that creativity. Now, a lot of times we throw the term AI out there and we misuse it quite often. But I think when we begin designing computers that can be completely creative, you know, a computer can't even generate a random number, right? It's based off the clock. So when we begin developing that, and I think that's currently beyond us, but is that impossible for us to develop? It seems like everything's going exponentially faster. You know, so I don't think that's far off.
Is the U.S. a major center for manufacturing of robotic technology?
Is the U.S.
Is it a major center for the manufacturing of robotic technology? Has all that stayed here, or has it gone to another big country?
Is the U.S. a major center for manufacturing technology or robotics?
Robotics.
For robotics technology. U.S. still has a significant presence, but it does go into foreign markets. Japan is a huge innovator in robotics, particularly personal robotics. So one day when I have my own R2-D2 unit that I dreamt about as a 6-year-old, it'll probably come from Japan. But do we still have it? Yes. Companies like Amazon have invested so heavily in robotics that we are still one of the leading manufacturers. We're not the. Places like KUKA actually comes from Germany, but was bought out by China. Fanuc is US based, I believe. So there's still a lot that is overseas. But then again, can we really meet the demand for robotics with our current manufacturing? Probably not. There's such a huge demand that we can't. Now, when the self-driving car industry, we are number one. Waymo is the leader in self-driving car technology by far, and that's US based. Yes, sir.
Do you foresee a time when all the fast food restaurants will be automated?
Do I foresee a time when all the fast food restaurants will be completely automated? No. I think there will always be a demand for the service industry, but in terms of fast food, I think we're going to see it change. The pandemic already saw a huge shift into drive-through service and takeout service and food delivery service. So I think we'll still see it. I think it'll look different though. Other questions? I appreciate your interest in technology. I appreciate your interest in STEM. That is my wife. Do not take a comment card from her. You're going to ruin my GPA.
All right, let's give Jody one more big round of applause.